The weather forecast says we're gonna get storms on Thursday. It is Thursday right now, so what do we get? Sun. Welcome to Cool Dude Clem's Electronic Workshop with me, your host, Cool Dude Clem. Well, hello and welcome back to the computer. Now don't worry, this is an electronics video. It's just about getting sound into the computer. So, you may remember, in a previous video, I bought this amplifier because I wanted it back. Now there's something this amplifier does that pretty much all amplifiers do, and that is it has a tape output. And I thought that I could connect this amplifier's tape output to the computer's line in so I could record from things. I could plug something into the CD tape port there and record from it. There's just one problem. The line input on my computer is so sensitive that even though I don't have it turned all the way up, I have it connected to this tape recorder at the moment, which is, you can see it's playing something. And even on the really quiet parts, it's blasting all the way. So I've got Audacity recording, and I've only got the volume turned up to 15%, and just look at how loud those loud bits are. It's overdriving the whole thing. Now I might be able to turn this down and get a good recording, but it's probably overdriving the line inputs anyway as it is. So I'm going to try and do something about that. So the reason why... Stupid chest. So the reason why I want to use this as a pass-through is so that I can actually hear what's going into the computer as it's going in, without having to do this kind of BS. So we've got some stuff playing from this tape into the computer. I can turn this up. Okay, yeah, better not play too much of that because copyright. I mean, yeah, that works, but this would just be much easier. Even when it rains, we get sun. What the actual F? So my next idea was to use this USB capture device. Now I usually use this to record from this camera. Right now I've got it connected up to this cassette recorder's output, and I'm recording something on Audacity. And although it does record in stereo, you can see we've got a bit of a DC output issue right there. DC offset issue, I should say. And it doesn't capture any of the low frequencies. I think there's like a 300 Hertz roll off in there.
Man not know how man did that.
And look what you've done, Nobby.
Rat.
How are Clem and Ricky supposed to get to school today?
I don't know. I'm good with this.
And we've all run out of things to say, and I fell over and got the sack, so good night, everybody.
Now,
Jane, just forget it. We've been talking about it for the past 5 minutes now. Just stop trying to think about it, okay?
Thing is, Ricky was here early.
I mean, yeah, that's fine for speech, but if you want to record music, you need the entire frequency range. So another idea I had was to use this. Excuse the blinking lights, but this is a USB audio dongle. It's got headphone output and microphone input. Although that microphone input's somewhere between microphone level and line level, even though it does provide the bias voltage for powering electric condenser microphones. So I'm recording something from that. And because it's a microphone input, yeah, you can see a lot of clipping here because it's just too strong for that input. So I thought maybe I could make an attenuator circuit for that, but it's completely mono. And if I want to do stereo recording with this just isn't going to be an option. Also, I should mention ground loops. So this is what I've come up with. Excuse the crudity of this drawing. I didn't have time to paint it, I didn't have, what was it now? I don't know. There, stop blowing about in the wind. Anyway, to clear up the ground loop issue, I'm going to use an audio transformer. Well, 2 of them actually, because it's going to be stereo. 10 microfarad capacitor on the input. 5 kilo ohm resistor here for fine adjustments. Also, that's going to prevent the transformer and the capacitor forming an LC circuit, because we don't want that. And a similar thing on the output, so potentiometer across the output coil, and then a 10 microfarad capacitor connected to the potentiometer, and it should work. Of course, I'm going to build 2 of these circuits, because obviously I want stereo, so I'm going to get on and do that. So I was just looking in one of my junk boxes to see if I got any audio leads, and I was going to use the connector from this pair of headphones that I found. Except if we look at the connector, that's not an audio connector. That's like some kind of USB or something. Maybe that's USB-C or something, and USB-C has headphone output or something, I don't know. But who puts a USB connector on headphones? Apart from someone who's absolutely crazy like me. Yeah, I can plug these into the USB and, yeah, they work. Okay, well I'm starting to prototype this. Build that up a little bit. Okay, well I'm starting to prototype the circuit here. You can see it on this little tiny breadboard. And these are the volume control ports. Although I'm only going to use one of them as a volume control. And I would have been so peeved. Is it this one or that one? Yeah, I would have been so peeved if I've used this one. And I'll tell you why. Because although these are both 50 kilo ohm potentiometers, they're not exactly the same. This one is a linear potentiometer, and this one is a log potentiometer. So with a linear potentiometer, it pretty much stays in step with how far you turn it. You know, it's a nice straight line or smooth slope, however you want to look at it. Thing is, those won't work for audio. You could just turn it up just a little bit and it's already going to be blasting. But with one of these logarithmic potentiometers, the resistance changes more and more as you turn it up. And these work great for audio. It's a nice curve, you know? So how do I know which one of these is linear and which one of these is logarithmic? Well, they both have their resistance printed on them, and if it starts with a B, it's a linear one, and if it starts with an A, it's a logarithmic one. So this is the one I'm going to use. Okay, so this is what I got so far. So I'm going to try it like this first, without the volume control. Oh, that's the wrong one. Without the volume control and without the capacitors, just to see how well it works. And we'll see where we go from there. Focus. Come on, there. Okay. Tape's playing. It's going through this. Going into the computer, and it's coming in loud. I've only got that turned up to 39%. And yeah, this is probably overdriving the audio input. Okay, well I had to transfer this onto a different board. So we now have the full circuit. Pay no attention to these capacitors here, they're not doing anything. You can see the input with the input capacitors sitting under those potentiometers there. And we've got the output capacitors and of course the two transformers, the most important parts. And the volume control. Okay, so this is all set up and ready. The circuit's in place. It may not look pretty. It's not about how good it looks, it's about how good it works. And that's connected up to the computer, so I'm going to bring up the sound settings. Come on, sound settings. Well, there's already something registering on there. I'm going to start displaying. And yes, I would say that's much more of an acceptable level. Let's just turn this up a little bit. Okay, that's too much. But does it sound any good? That's the question. Okay, well, let me just minimize that. Bring up Audacity. I don't know what I'm moving my voice then. Okay, here's Audacity. I think it's already set up for the recording from the line input. Yep, we're getting something. Maybe a little too loud on one of the channels, but we got something. We got stuff going in. I have no idea what it's recording, but we'll find out in a minute. Well, it is working, but the recordings it's making are very tinny. So, I'm thinking maybe it's the input capacitors. So I've taken them out. Now I'm just bypassing them. I'm going to try recording again, and we'll see what this gives us. So I'll be back when this is done. Well, the results are in, and it's not good. These little transformers are just making the sound too tinny. So, I decided to remove them and go with something else. Unfortunately, this means that the grounds are going to be connected. So we've got one main volume control here, and this one is to, so in case one channel's louder than the other. So first our audio goes into a 75k resistor. Why 75k? Well, that's because that's the first resistor I came to. Then we got a 7.5k resistor here, which will take the right channel down, which will reduce the right channel down 10 times, and then it goes into the 50k output potentiometer, so I can actually adjust the volume. And of course on the left channel we see the same thing, but with these two resistors here, so I can balance the two channels, and yeah. Well, enough waffle, let's see how well this works. Well, the tape's playing, and it's going through this, going into the computer, and we have sound. I don't know what's actually on that tape, but there's definitely something coming through. So I'm just recording it into Audacity right now. It's probably me saying stupid stuff. That's what's usually on my tapes. It is coming in a bit strong, so I'm going to turn this down just a little bit. And yeah, I think I'll turn it down a little bit more than that. Okay, that's looking more like it. The right channel is a little bit faint, so I'm going to turn this until they both match, because this is a mono recording. Alright, well, let's see what we captured. I've no idea what's going on there. Probably next door's music.
Ricky, what are you doing in Clem's bed?
Oh, I'm having a sleepover with Clem. It smells out a little.
Ricky, when I said you could have a sleepover with me, I didn't mean you could have a sleepover with me. I said none of that stuff. Get out of my bed.
But I'm a 10-year-old child. I thought you'd be happy that your child is in your bed with you. Because, well, we kids like to cuddle up to each other. I don't you want to cuddle up to me.
Ricky, if you say one more creepy thing, I'm going to stick your head up your bum. So let's go to a little later on.
Clem,
Yes, Ricky?
what's that noise?
It's my neighbours. Got the music on again.
Doesn't sound like music.
Well, I know. That's what they call it.
So yep, this is the final design I've come up with. Not going to change it anymore. This is what I've done. So with the same 75 kilo ohm resistors in series with the inputs, and with these two potentiometers in their, like, middle position, that's about 7.5 kilo ohms, so that's like a 10 to 1 reduction, which should be just about right. One thing I've got to remember is that this one is backwards, so turning it this way is actually turning it up. It's just the way I wired it. Well, I suppose you want to see the schematic of that, so there you go. These aren't exactly volume controls, it's more of a kind of fine adjustment. But yeah, so I've put everything in. I've got some tape in there, I don't know what it is, but some music on there. Hope I don't get nabbed for copyright. Anyway, got the line out of this cassette recorder going into this amplifier's CD tape in. I've got this set up. It's still very sensitive even with the circuit in line, but 30% seems to be a good level. So I'll start this recording and I'll start the tape playing. I won't play it too loud and I'm going to talk over it so I don't get nabbed for copyright, but yeah, you can see that's coming in pretty good. Now I'm going to try to adjust the levels. If I can just get it, I don't know which one I'm doing here. Okay. That's the left, just to see if I can make that a little bit more balanced. Please don't nab me for copyright, YouTube. There we go, we got a nice volume level. So I can compensate for the imbalance in the left and the right. Actually, this thing has gone completely off track. But, you know.
Yeah, your face doesn't make any sense. Oh, what do you know, Teenage Ricky's here? Hi, Teenage Ricky, how are you doing today? Terrible. That's good, isn't it? We had a problem with the microphone and it was making...
Oh, Willy, penis, Willy. When everything goes wrong, it's always me, isn't it? It's always blame the microphone.
High frequencies are gay. Glad you agree with me. No, I mean, why do you think high frequencies are gay? Well, they're gay because... they're gay. You know, Ricky, you've really got to start thinking of...
You want me to think? You know I can't do that. I'm a teenager, I can't think. You didn't let me finish. Oh, what was it you were going to say then? I was just going to say that you've got to start thinking of other words besides gay. It's very offensive to gay people. 'Cause you're gay. I can't be gay, I'm a girl. You must be gay because you don't want me to feel your boobs. Ricky? What? Can I hit you with them? Gonna do it anyway. I'm going to say this is a success. And until next time, goodbye.